What is the set of points that are in equal distance from the point 0, p and from the line y equals negative p? Well, what does it mean for a point to be an equal distance from those two things? Well, if we have something x, y, that the distance to the line is the straight line distance. So the distance to y equals negative p is going to be y plus p. So this distance is y, this distance is p, so we have y plus p is the distance to the line. The distance to 0, p is by the distance formula. So square root of x minus 0 squared plus y minus p squared equals y plus p. So let's solve this equation. Square both sides to get x squared plus y minus p squared equals y plus p squared. We can expand these y minus p squared and y plus p squared. We get x squared plus y squared minus 2yp plus p squared equals, the other side is a perfect square trinomial, 2yp plus p squared. You'll notice that y squared and p squared are the same on both sides of the equation, so we can cancel those out. What we'll be left with is x squared minus 2yp equals 2yp. Add 2yp to both sides and we get 4yp equals x squared, and typically we write that as 4p times y equals x squared. So this is clearly the equation of a parabola. The parabola has a center at 0, 0, and 4p, that 4 arises when the distance to the focus and the directrix is p. So we're learning about focus and directrix of a parabola. We have 4p times y equals x squared, so focus is that special point. And the directrix is a line. These aren't definitions, but the idea being that we have the distance to the focus and the distance to the directrix are the same. So that distance and that distance have to be the same if this is the focus and that is the directrix. The other special property about the focus is if we have something bounce off this line, it will always go through the focus, which is a special thing that gets used in physics when you're trying to collect a signal, so something like a dish, a satellite dish. If we take that equation and shift it right by h and up by k, all we're doing is switching y for y minus k and switching x for x minus h. So now this has a vertex at h, k. The focus is p above that, so the focus would be at, well, we want to increase the y-coordinate by p, and the directrix, we want to decrease the y-coordinate by p, so that would be y equals k minus p. We can do the same thing with a horizontal parabola, and that would have a focus here, a directrix there, and here the vertex is at h, k. Now that it's to the right, we have the focus. We add that p to the x-coordinate, and the directrix is x equals x equals, and now we go left by p from h, so h minus p. So some example problems. For the following equation, find the vertex, focus, and directrix. Use this to sketch a graph of the equation. So the vertex is the easy part, 2 and -5. This 6, that's -6 is equal to our 4p. It's taking the place of 4p, so p equals -3/2. So based on that, we can say that our focus, we're going to take our 2, -5 and add it in the direction that we should be going. Well, this is a y², here y², so that tells me that it's a horizontal parabola because the y is the squared part. So therefore, I am going to add the -3/2 to the x-coordinate, and then we get 1/2, -5 is the focus. So let's see. Plot 2, -5, 2, -5. Plot 1/2, -5. That's the focus. The directrix will be on the exact opposite location. So it'll be over here. Or we could do it algebraically by saying, instead of 2 minus 3/2, we have x equals 2 minus -3/2, which is 7/2, or 3.5. So that's our directrix. And we can use that to sketch a graph of this equation. Now, depending on how careful we want to be, we can figure out what the y-intercepts are, or what the x-intercept is. But there's a reasonable sketch of this graph. Write the equation of a parabola with focus 2, 8 and directrix x equals -10. So let's see. For me, it helps me to visualize these things. So if I graph it, so 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And the directrix is at 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to make more space. Don't you wish you could do that on your paper? 10. So we know that here is going to be our vertex, and if we want to just do that without the graph, we can say its x-coordinate will be halfway between the focus and the directrix, because the distance, what we said before, the distance to the focus is the same as the distance to the directrix. So we can average the x-coordinates. 2 plus -10 over 2 equals -8 over 2 is -4. That is the x-coordinate of the vertex. So that's h. K is going to be 8. Because I identified that this is a horizontal facing parabola, that's why I know that K is going to be 8. So horizontal facing parabolas just take the focus and the vertex have the same y-coordinate. With the vertical one, the focus and the vertex have the same x-coordinate. And then, now that I have -4, 8 as my vertex, now I need to find P. So how far away is -4 from -10, say? This is -4, 8. Here's -10. So how far apart are those? That's 6. That's a distance of 6. So that tells me that that P equals 6. Now we have enough information to figure out which parabola we're writing. I'm either going to write y minus k times 4p equals x minus h squared, or I'm going to write 4p times x minus h equals y minus k squared. Because this is a horizontal facing parabola, I know that, again, because the directrix was x equals. That tells me I'm going to use this equation. Once I identify that I'm using that equation, I substitute in h and p. P is 4, so that becomes 24. H is negative 4, so this becomes positive 4. And k is 8. And there is our answer. Thanks.